Atomic structure, class 7 to 10. In this video, we shall learn about the various theories proposed by different philosophers and scientists all over the world over the centuries about the structure of an atom, which is considered to be the smallest particle of all the substances found in the universe. We know that atoms are the smallest particles of all things that occupy space and have mass, that is, matter. All matter, whether solid, liquid, or gas, are composed of very tiny particles which cannot be seen with our naked eyes or even standard microscope. The average diameter of an atom is equal to 1 into 10 power minus 9 meter or 1 nanometer. 7 billion atoms are found in human body, of which 98% gets replaced every year. The Indian philosopher Kanada 500 BC called it as Parama Anu, and the Greek philosopher Democritus 450 BC called it as atomos. The first scientific theory about the structure of an atom was proposed by John Dalton in 1808. Dalton's atomic theory. In his theory, Dalton proposed that atom is the smallest particle of any matter. It cannot be divided, that is, it is indivisible. It is spherical in shape. Atoms of different elements have different size, mass, and properties. Atoms can neither be created nor be destroyed. Atoms of different elements combine with each other in a fixed simple ratio to form molecules. That is, two hydrogen atoms combine with one oxygen atom to form one molecule of water. 2:1 is a simple fixed ratio. Atom is the simplest particle of matter that takes part in any chemical reaction. Advantages of Dalton's theory. Though recent researchers have proved many failures in his theory, there are few advantages of Dalton's theory. Number 1, it explains most of the properties of liquids and gases. Number 2, the law of chemical combination and law of conservation of mass could be explained. Number 3, it helps in finding the molecular differences between elements and compounds. The later scientific discoveries have proved the failure of Dalton's atomic theory in certain statements. After the discovery of the subatomic particles, the protons, neutrons, and electrons, atoms are no longer considered as smallest indivisible particles. After the discovery of isotopes, that is, atoms of same element having different number of neutrons in the nucleus, atoms of the same element are found to have different masses. After the discovery of isobars, it was found that atoms of different elements had the same atomic mass. It was found that substances made of same kind of elements had different properties. For example, coal, graphite, and diamond are made up of the same element carbon, but they have different properties. He did not propose about the charges of an atom, so his theory was unable to explain the different properties of matter, and this was considered as a failure of his theory. In 1897, JJ.Thomson, an English scientist, proposed the atom to resemble the shape of a sphere having a radius 10 power minus 10 meters. He compared the atom to a watermelon and said that an atom has a positive charge in which the negative charge is embedded, just like the seeds embedded in the red part of the watermelon. He called the negative part as electron. He said that the negative charge was equal to the positive charge, and so the atom had neutral charge. JJ.Thomson was awarded the Nobel Prize in 1906 for his discovery of the negatively charged electrons in an atom. Failures in Thomson's atomic model. His theory failed to explain how positively charged sphere did not get neutralized by negatively charged electrons. It did not explain about the presence of neutral particles in the atom. In 1911, New Zealand-born scientist Rutherford proposed his theory. Rutherford bombarded a very thin layer of gold with positively charged alpha particles. He found that most of it passed through without any obstruction. Some of it got turned back. Some got slightly deflected. Based on his observation, he proposed a model of atom called Rutherford's atomic model. He proposed that the atom contains large empty space since alpha particles pass through easily. There is a positive charge at the center of the mass called nucleus. Since some alpha particles gets reflected or turned back because the positive alpha particles are repelled by the positive charge in the center of the atom. Size of nucleus is very small compared to the atom. The electrons revolve round the nucleus in circular paths called orbits. The atom is electrically neutral, that is, number of positive charge protons is equal to number of negative charge electrons. His model is similar to the solar system. Rutherford's theory states that the nucleus at the center of an atom has positive charge. The mass of an atom is concentrated in the nucleus. Negatively charged electrons revolve round the nucleus in specific orbit. The nucleus is very small compared to the atom. In 1920, Rutherford predicted the presence of another particle with neutral charge in the nucleus. His student James Chadwick later found the presence of the neutrally charged particle and named it as neutron. Rutherford received Nobel Prize for Chemistry for his theory. Failures of Rutherford's model. It failed to explain the stability of atom. According to electromagnetic theory, a moving electron should lose energy. If it loses energy, it should fall into the nucleus at last. If such a thing happens, then the atom will not be stable. But atoms are stable, so Rutherford's model failed. In 1913, Rutherford's student Niels Bohr, a Danish scientist, tried to explain the cause of the atom's stability in a different way. He said that in an atom, electrons revolved in stationary concentric circular paths around the nucleus. These paths were called orbits or shells or energy levels. The electrons did not gain or lose energy while moving around the nucleus. The electron can move from a lower shell to higher shell by absorbing energy and fall from a higher shell to lower shell by releasing energy. The orbits or shells are represented by the letters K, L, M, N or 1, 2, 3, 4. The orbit closest to the nucleus is named as K shell and it has the least amount of energy. The next orbit L, then M and N. Each orbit had fixed amount of energy, so they are called energy levels. Failure in Bohr's model. Bohr's model failed because it was applicable only to atoms with few electrons like hydrogen, helium, beryllium, etc. It was not true with multi-electron nucleus. Schrödinger, an Austrian scientist, in 1926 proposed the quantum mechanical model, which is the basis of the modern atomic theory. After the discovery of electrons, protons, neutrons, the nucleus, the isotopes, isobars, and the artificial transformation of one element to another element, the modern atomic theory was proposed. Modern atomic theory states that an atom is no longer indivisible because after the discovery of electrons, protons, and neutrons, it was found that atoms can be divided further into subatomic particles. Number 2, atoms of the same element may have different atomic mass. That number of protons plus number of neutrons is equal to the atomic mass of the atom. After the discovery of isotopes, it was found that the same element can have different number of neutrons in its nucleus and so its atomic mass can differ. Example, chlorine 3517 and chlorine 3717 isotopes. Chlorine atom has 17 protons and 18 neutrons in chlorine 3517 isotope and 17 protons and 20 neutrons in chlorine 3717 isotope. So, the atomic mass varies. The discovery of isobars led to the proposal that atoms of different elements may have same mass. Example, elements argon and calcium were found to have same mass. Argon 4018 and calcium 4020 are called as isobars. The discovery of radioactive elements led to the conclusion that atoms of one element can be changed into, that is, transmuted into atoms of other elements by the process called artificial transmutation. Example, uranium 238 emits alpha particles, helium 42, and forms thorium 234. UR 23892 gives TH 23490 plus helium 42. Uranium 235 bombarded with a neutron forms the element barium and krypton. UR 23592 plus neutron gives barium 14156 plus krypton 9236 plus 3 neutrons. Atoms may not always combine in simple whole number ratio. Example, the ratio of carbon, hydrogen and oxygen in glucose C6H12O6 is 6 is to 12 is to 6 or 1 is to 2 is to 1. But in sucrose C12H22O11, it is 12 is to 22 is to 11. So the ratio is not a simple whole number. Number 6, atom is the smallest particle that takes part in a chemical reaction. And one hydrogen atom combines with one chlorine atom to form one molecule of hydrogen chloride. Number 7, the mass of an atom can be converted into energy, where energy E is equal to mass into speed of light square, that is equal to mc square. In recent times, the modern atomic theory has become the basis for all the studies of physical and chemical processes involving atoms. Hope you have understood clearly the different theories on the structure of atom proposed by various scientists over the centuries. Thank you. Please like, share, subscribe and click the bell icon.